Well, hello, Internet, and welcome to what I think is going to be a pretty crazy video. I am going to try to teach Algebra 1 and 2. Normally, kids take multiple years to learn Algebra 1 and 2, and I'm going to try to do it in one video. So what exactly is this video going to be? Well, I am going to focus on the hard stuff, because people often say to me, well, I know algebra. And then I show them a formula and they say, maybe I don't know algebra. So I am going to really focus on the hard stuff, but I'm going to start off by going over the basics real quick. And of course, if you have any questions, this is a live stream, at least it's a live stream right now. You can go and ask me any questions. Like if you say, I want to see more problems like that, say, I want to see more problems like that, and I'll solve them. The way I structured this is I'm basically going to solve every type of algebra problem you could ever see. And I'm going to, specifically, I'm going to target problems where you solve them using one rule, and then I'm going to show you the same similar problem that is solved using other rules. And I'm hopefully, if you go through this video, pause when you see the video, try to solve it, and then watch how I solve it. If you do that enough times, I think that you basically will master algebra and be able to solve any type of problems. Well, I will, what will you cover? This isn't an octave video, this is an algebra video. And I'm going to basically cover all of Algebra 1 and 2 except for matrices. I'm going to cover those in a Learn Linear Algebra in one video, because I thought that kind of made sense, and this video is already going to be super long. So let's jump in and to the presentation. And I am going to be drinking a lot of water. So here we are, some basic random algebra things on the screen. Let's start off very basic, and it will ramp up very quickly. Of course, a variable is a variable. If you don't know what that is just a letter that represents a currently unknown number. This is going to be targeted towards anybody that wants to learn algebra, which can be used, of course, in programming. And I'm mainly making this because I want a complete course on machine learning and data science, and a complete understanding of algebra is needed to be able to do that. Of course, knowing algebra also would help dramatically with games. Okay, so a variable is just no problem. And believe me, by the end of this, I'm going to show you pretty much every algebra problem there is. Okay, except for matrices. I'm going to cover that later. Okay, so we have variables. It's just a letter that stands for an unknown number. Then you have what I guess we're starting to get a little bit more complicated, mathematical expressions. What is a mathematical expression? Well, this is a term right here, and a mathematical expression is just 3x, or you could go and add on a 5, or you could go and add on 2y, whatever, okay? So this is an expression. Then you have what are called monomial expressions. It's just one term, okay? So this guy right here is called a monomial. Now, binomials have 2 terms, trinomials 3 terms, and thank you very much for subscribing, Zen. Polynomials cover 2, 3, or more terms, along with a whole bunch of different math operators. Then you have equations. An equation is how it separates itself from a simple mathematical expression. Is an equation has an equal sign. That's all. So 7x is equal to 14. And can you solve that problem? That is a equation. Inequalities, they are going to be anytime you see a less than symbol, a greater than symbol, a less than or equal symbol, greater than or equal to. You could say not equal to or not equal to, whatever you'd like. Okay, so those are inequalities. Like terms, what's a like term? Well, if they have the same variable, they are like terms. So these are like terms, and for example, 7z, this would be an unlike term in comparison to the other terms that you see on your screen. Get a little bit more jargon out of the way. If you had something like 7a, this guy right here, this number is called a coefficient, and can you guess what this is called? It is called a variable. All right, and I think that covers a lot of the basics. You can basically, let's go and erase this so that we can get more stuff here on the screen. I'm covering all the basic stuff really quickly so that I can spend a lot of time doing very complicated stuff. Thank you very much. All right, I obviously use algebra constantly. All right, so we can add like terms. So if you had something like 3x plus 7x, these could be added to give you 10x. Now you cannot add 3x plus 4y. Why? Because they're unlike terms. Why are they unlike terms? Because they use different variables. And you can also multiply, you can also subtract like terms. You can't subtract unlike terms. You can multiply like terms, so this would give you 2x. What else can you do? You can multiply a number times a variable, so 3 times x is going to be equal to 3x. All right? So basic stuff, but extremely important to be able to understand. You can also multiply expressions that have unlike terms, and you can also divide expressions that have unlike terms. Or I should say, you can also multiply and divide terms. So, for example, if you had 3x times 2y, this would be equal to 6xy. Exactly like that. And like I said, anything you can't add or subtract unlike terms, but you can multiply and divide them. Go ahead, what's your question? Hey? Somebody just said hey. I'll just continue on. So, for example, if you had something like 3x divided by 4x, what would happen? These would cancel out. We can erase them. It's just as if they didn't exist. Why can they cancel out? Well, x over x is equal to 1. So this is exactly the same as saying 3/4 times 1. Well, what's that going to give you? It's going to give you 3/4. All right? So simple stuff. What else? Give me a bigger eraser here. Okay. So what else can we do? Well, I'm not really going to cover order of operations because I kind of think that's pretty simple. Let's start getting into a little bit more complicated stuff. And of course, if you can subtract, and you can't divide by 0. We'll get more into those rules. We're getting into some rules right now. Now, whenever it comes to what are called properties of numbers, there is the commutative property of addition. And it just means you can add your values in any order and it doesn't matter. So a plus b is exactly the same as b plus a. The commutative property of multiplication, I know my daughter took algebra and she had to memorize these names. I leave that to you to figure out how to memorize them. Basically, the commutative property of multiplication says that you can multiply in any order and get the same exact result. You can also, based off the associative property of addition, you can add a group of numbers together in any order and also get the same results. The associative property of multiplication says when multiplying, you can also multiply in any order, all right? And then we get the distributive property of multiplication, and that just says that a times b plus c is going to be equal to a times b plus a times c. All right, so pretty easy. Now we're going to get into a little bit more complicated. We're going to talk about solving equations. Now, how do we solve equations? Well, the very first thing we want to do is we want to simplify each side of the equation. What does that mean? Well, it means that we're going to be adding and subtracting like terms. And then after we do that, we're going to be dividing or multiplying unlike terms. So if we had something like 4x plus 2x minus 7 plus 9, well, basically, you just want to look at these as their like term types. So those are like terms, or maybe I should use a slightly different color. Here we'll go. There's a like term, there's a like term, and these are like terms. All right, so there you are, and you just add them together. So if we have 4x plus 2x plus x, what's that going to be equal to? Well, it's going to be equal to 7x. Then you get 9 minus 7, which is going to be equal to plus 2, which is then, if you take 5x minus x, you get 4x. And then you're left with bringing the 4x over. How do you do that? Well, you subtract the 4x from this side. Anything you do on one side, you have to do on the other side. This leaves you with 3x, and then you have to bring the 2 over. How do you do that? You subtract 2 from this side, you subtract 2 from this side, and you're left with 3x is equal to negative 2. Then you want to get rid of the 3. You can multiply and divide unlike terms, so of course the final answer, well, let's write it out. So you need to divide this side by 3. Can I draw 3 that's legible? I think I might be able to. And you divide both sides by 3. Well, that cancels these out. You're left with x is equal to negative 2 over 3. All right? So there's an example of just solving a simple equation. Let's ramp it up a little bit more. Solving inequalities. Again, remember, solving an inequality, anytime you see these types of little symbols, that means that we are going to be working with what are called inequalities. Whenever you have the situation in which you have greater than or less than, whenever you're drawing these on the number line, you're going to draw an unfilled circle. In circumstances in which you have an equal sign, you're going to draw a filled circle. All right, so that is the difference between drawing these onto a number line. So let's just keep it very simple. Let's say that we want to graph x is greater than 2. Well, it's not greater than or equal to, so what does that mean? We are going to use a circle number. So a number that's not, we're going to be using a circle that is not filled. So we're just going to go like this, and we're going to go like this, and there you go. You just graphed it. So let's go and do something slightly more complicated. So we have 2x minus 5x plus 4 is less than or equal to 10. One thing to also understand is anytime you divide by a negative value, that you are going to have to flip this guy right here. So if you're going to be dividing with a negative value, this is going to become greater than or equal to. All right, and I'm going to show you that in this example right now. So we have 2x minus 5x. This is going to be equal to negative 3x plus 4 and less than or equal to 10. We want to get rid of this 4 on the left side, so we have to go and subtract 4 from both sides. That's going to leave us with negative 3x, and that is still going to be, you can see there's negative values here, so we're probably going to be flipping. And let's subtract the 4 from the 10. That is going to give us negative 3x is less than or equal to 6. We're going to need to divide by a negative 3 on both sides to get the x by itself. Remember, if you're going to do that, you have to flip the inequality, and you're going to end up with x is greater than or equal to negative 2. Now we have the greater than or equal to. That means we're going to be using a filled value. So we're going to find the negative 2. We're going to draw it on the number line exactly like this. And x is greater than or equal to negative 2. We're just going to go and draw our line, maybe nicer than that, exactly like this. Okay? And there you go. That is how we solve inequalities. That brings us to rate of change. Yeah, thank you for following there. That's an interesting looking face. It's like a kind of falling asleep face, and then it is a waking up face. Okay, so rate of change. Now we're getting into what is called slope. And which do I want to use here? Let's probably use the x. Now the rate of change or slope is going to indicate both the direction and the steepness of lines. And we're starting to get into more complicated things here now because this is actually pertains to calculus. So let's say that we just simply have x is equal to, can you see that? I think you can, negative 3. How would we go and plot that on our little graph here? Well, we just find negative 3, which is right here, and we would just draw a line like this. Okay, so there you are, you just graphed that. Now, however, let's say that y is equal to negative, whoop, don't put it there, I can't draw anything if I put it there. No, y is equal to negative 3. How would that be drawn out? Well, again, we find our negative 3. So 1, 2, 3, which would be right here. And we would draw our line in exactly like that. And don't worry, we're going to get a lot more complicated than this. Is this a formal class you're streaming on Twitch, or are you just streaming education for fun? I'm just making education videos for fun, I guess. Yeah. I assume there's some people watching. It looks like there are, so that's a good thing. So positive rate of change means that a line is going uphill. So this would be an example of a positive rate of change, and this would be an example of a negative rate of change because it is going downhill. All right. What would we like to do? Let's move on here. Let's go and let's say you had to create a line and you wanted to do so using just 2 points. How exactly would you figure those out? Well, you would have to use this formula over here. Remember, we were talking about rate of change and slope. Well, this is a formula that is going to allow you to find rate of change or slope. I'm just going to call it slope because slope is easier. So what do? We just go and we take our value right here. See, we're just using this formula right here. And we're going to take our 2 that we have right here and minus, but we have a -8 here. So we're going to put a -8. And I'm pretty certain you understand that if you subtract a negative number, that is just like adding it. Will you be streaming calculus? Yes, I am going to bang out Algebra 1 and 2, linear algebra in one video, and probably trig. And basically the trig video is going to be all the trig you need to know calculus. And then I'm going to probably create learn calculus in one video, calculus 1, and then calculus 2. They'll probably be two separate videos, if this goes well, if people like it or not. Okay, so now we got to worry about this guy over here and this guy over here to calculate slope. So we're going to have -6 and minus and a -3. So there we are. And this is going to then give us 10 divided by -3. So now we know, just with these 2 points on a graph, we now know the slope of our line. So what do we need to do now? Well, we need to find what is called the y-intercept. Again, some more jargon that sounds complicated. It isn't. It is just that point in which our line hits the y-axis of our graph. Thank you very much for subscribing, Granny Found Switch. I appreciate it. Okay, so we need to find that y-intercept, and the y-intercept is just that point in which our imaginative line that we're trying to discover hits our y-axis. And it is a line, so it's, only going to hit the y-axis in one point. This is also my pencil. Okay, so how are we going to figure that out? Well, what we're going to do is we are going to go and use this handy-dandy formula right here. Y is equal to mx plus b. And then what we can do is we can go and actually plug in our slope, which we just discovered, and we can plug in some values. So what I want to do is I'm going to plug in this value, this 2 up here, and this -6. If I do so, well, this is y, of course. So I'm going to say 2 is equal to, plug in our slope. That is what the m is in this situation, our slope. And then this right here, the b is going to be, well, we're going to figure out the b in this situation. It is the y-intercept. All right, so let's plug in our slope, -10/3. And this is going to be multiplied times what? This 6 up here. I keep drawing arrows up here. Hopefully that's not confusing. So we're going to multiply that times -6 and then plus b. B is our y-intercept that we want to discover. So we just go and use all the wonderful stuff we just learned before. We're going to get 60. If we multiply -10 times -6, we get 60, and we keep this 3 right here, plus b. And if we then work that out, that's going to end up being equal to 2 is equal to 20 plus b. And that means that our y-intercept is going to be -18. So we found our slope. Just with these 2 points, we found our slope. We know exactly what the slope is for our line, and we also know what our y-intercept is. With that information, we also know the formula for our line. We can just simply say y is going to be equal to our slope, -10/3, x minus 18. And there you go. That is how you take 2 points and you discover a line. Let's see. Let's go and also take it to the next level. Let's say we want to graph a specific line. How would we do it? What's going on? Just went to the dividend, making a Twitch account. Well, thank you very much. Thank you very much. I greatly appreciate the help there, Granny found Twitch. It is super awesome. Y equals mx plus c. That works. Whatever. It's the same thing. B, C. I don't know. I'm sure they would like to put, I would work. Whatever. It's all math, and the symbols are just there just to designate unknown values. So let's say somebody goes and they give you this weird thing and they say, hey, I would like you to show me how to graph this line. Well, what are we going to do? Well, we're going to find our x-intercept just simply by making y equal to 0. All right, so it's very simple. Remember, we're working with straight lines here. As the video continues, we'll get into more complicated functions that start doing all kinds of weird things. Right now, we're working with lines. Everything's easy. So we just find the x-intercept by making y equal to 0. And if we do that, we get 3x is equal to -6. And that means that x, whenever y is equal to 0, is going to be equal to -2. And then we come over here to our little plot. X is equal to -2 and y is equal to 0. And we put a dot right there. What do we want to do next? We want to find our y-intercept. How do we do that? Well, we can just go in and say -4y is equal to -6. Again, I'm just making x negative this time. And this means that y is going to be equal to 3/2, or approximately 1.5. So what do we do here? Well, remember, x is going to be equal to 0. That means y is going to be equal to 1.5, and that is going to be approximately right there. Since we know this is a line and we have 2 points, we can just quite simply come in and draw a semi-straight line between those 2 points. Yes, I know I did not perfect that, but pretty good stuff as it goes. Now let's go on. Let's say we wanted to find the equation of a line, and we know that our line has this 1 point right here, -3 and 1. And we also know that it is parallel to this formula right here. Well, by being parallel, that just means that it has the same slope. So what we're going to do here is, we're going to graph this guy out. So I'm going to say that I want this guy right here to be negative. I want to calculate the slope for it because I know it's exactly the same as my line. Let's go and use a different color here. So I'm going to say -4y is going to be equal to -x plus 1. And in that situation, we can divide by -4 to get rid of that and get y by itself. And if we do that, we're going to end up getting y is equal to 1/4 x minus 1/4. And in that circumstance, what does that tell us? Well, we remember this formula right here, y equals mx plus, and I'll use the English version, y equals mx plus c in this situation. That means that this guy right here is the slope, and it's also the slope of our line. So pretty easy stuff. So now what I want to do is I want to find my y-intercept. How do we find the y-intercept? Well, we just make x equal to 0. So if we do this, that means that this is b is going to be equal to 4/4 plus 3/4, which is going to be 7/4. And it's kind of a mess. But what we ultimately know is the formula for our line is going to be 1/4 x plus 7/4. Okay? There you are. So that's how you can go and create a line if you know a singular point and you know another line that would be parallel that we could use to make that calculation. So how do we find the distance between 2 points? This is another formula. I used to talk to people all the time. I used to tutor people in calculus. Calculus has been brought up. Calculus is always brought up every time math is talked about. I apologize. I have to drink water or I will lose my voice. Okay, so basically, the reason why I used to tutor kids with calculus, and on the first day, you know what I always did? I brought one book with me. Was it a calculus book? No, it was not a calculus book. It was an algebra book. And by the way, I think I can make all these notes available to you for free for downloading if you want. If you want that, just say you want it, and I'll put them somewhere where you can get it. At the end of the video, I'll post a link or something. I don't know. Okay, so if you want these notes, if you don't, well, whatever, who cares? So anyway, I always brought an algebra book because the reason why most people I found, I'll make, it's a good notes thing and you can just download the whole thing. I just have to upload it somewhere where you can get it. I'll probably put it in Microsoft OneDrive or something like that. Okay, sorry about getting deviated there. So what I found was almost everybody that struggled with calculus really wasn't good in algebra. And you're going to see as we get later in this video all the really complicated algebra that everybody sort of struggles with. Can you recommend a good algebra book for self-learning? I like, probably my favorite, see, I like to learn by solving problems, and then if I get it wrong, I go, okay, well, why did I get it wrong? And I take a note, and then I try to solve some more problems, and then I go back. That's kind of what I've tried to do here with this video series. There's so many good algebra books. For basic algebra, I would say Painless Algebra is a real, if you're just starting off with algebra, I'd say Painless Algebra is probably a spectacular book. And if you are more of a problem-solving learner, I would recommend the Humongous Book of Algebra Problems, I think it's called. I think that's what it is. What syllabus are you using here? I basically just, I went and got an Algebra 1 and Algebra 2 book, went through and recreated to make sure that I have, by the end of this video, that I will have solved every type of algebra problem that you could possibly have based off of different rule changes that are needed depending upon what type of problem you're working with. So it's sort of my course. I've been making courses on YouTube for 14 years. So I've made like over 1,000 videos. I've probably made more courses than just about any human being that lives. So that's what I'm basing everything on. Okay, so how do we find the distance between these 2 points? We just use this nice formula. And I got deviated when I was talking about calculus, but basically I think learning algebra is more about just learning these formulas, writing them down, creating a cheat sheet, referring to them over and over again, and then all of a sudden that's all algebra is. It's just a bunch of rules. If you memorize the rules, then algebra all of a sudden becomes easy. I'm going to cover all the rules. Okay, so how do we solve this? Well, we're just going to take 11 minus 6, and we are going to square that, plus and 4. And normally in math, if you're squaring values like this, it normally means your ultimate goal is to eliminate a negative. So anytime you see, why are you squaring and then taking the square root? Well, the reason why is we want to have a value that's positive, all right? And then if you go and you work all of these out, what you're going to end up having is 5 squared. And of course, if you take the square root of 5 squared, they cancel each other out. That's another algebra rule. And you're going to end up with a value of 5. All right, so that's the distance between those different lines. Let's go into a little bit more jargon. There's something that is called interval notation. This is just so that you can recognize. Okay, so in this circumstance, you're not going to... I'm going to get into all of the other different terms as we continue. Okay, so we have 3 and 6. Okay, so how is this going to be? Or x is less than or greater than or equal to x and less than or equal to 6. How would we draw that? Well, we would just simply say 3 and 6, exactly like that. Now, in the circumstance, and that's because we are using the equal to signs. If we are using a less than sign or not an equal sign, this is going to be drawn out as a parenthesis and 3 and 6. Again, you see the greater than or equal, that means you're going to do the square brackets. And of course, this is going to transpose down here as well. So if we have 3 and 6, again, we're going to use parentheses here. Well, I'm covering algebra today because I want to cover machine learning next after I just made a ton of data science videos. And I've basically made this I'm making this video so that I can time code it, and anytime somebody asks me a question in my machine learning videos or any of my data science videos, I can say refer to this part of this one video. It just makes it very easy for me to both teach algebra, and also at the same time it makes it very easy to answer people's questions, because I'll be able to refer to a time code for this one video. So that's the reason why I'm doing it. Math is ridiculous. Like, if you don't know math, you might as well just give up on machine learning, because all machine learning is math. So that's why I'm covering math in a software world. Okay, so here, what do you think we need to use parentheses or bracket-wise? Remember, we have two that are less than. We do not have less than or equal to. We're just going to use parentheses, all right? So this is just a basic thing. It's just mainly covered so that you know how to be able to, properly use notation in mathematics. Okay, so what I want to do here with this equation we have here is convert it into interval notation. Well, that basically means I need to solve this inequality. Very simple. We're just going to say 6x minus 8. And I say very simple. I apologize for that. I don't mean to necessarily mean that it's particularly easy. So if you do have a question about something, hey, most people are not good at math. So if you have everything or any problems, feel free to ask me. This is just what I do constantly for my entire life, and so I'm good at it. Anybody that wants to see me do something really bad, watch me play chess, because I'm terrible at it. Okay, so that was learning chess. Actually, really taught me a lot about the difference between people that learned a skill very young and continued to develop it over numerous years. Multiply inequalities by... Oh, yes, I covered already about what happens with flipping the inequality if we're doing any type of division with negative values. Thank you for bringing that up. Okay, so let's continue. We got this. We're going to quite simply just simplify this. This is going to become, again, we're dividing by a negative, so we have to flip the inequality. This is going to be, flip that inequality, and this is going to be negative 27 over 4. But remember, our ultimate goal was to convert this into interval notation. And again, we're using greater than or equal to, so that means we're going to have square brackets, and then we're going to put negative 27 over 4, and then this is going to be infinity. And what do we do with infinity? Well, we actually use parentheses because it's not defined. All right, so let's graph some more stuff. Thank you to everybody that's joining me. I'm glad that this is something this is ridiculously important. But the problem is most people say, I know algebra. And then you find out they don't. Okay, so this is the slope, remember? And what is this? This is our y-intercept. So y-intercept. And of course, you know that is where the line hits the y-axis. So I'm going to actually graph this time. So, and graphing a inequality is quite weird because you have to shade underneath the line. You have to know where to shade underneath the line. So what we're going to do in this circumstance is I'm just going to go and put 0 inside of here, less than, and negative 1 over 3. Why did I pick 3 for so many things? I have such trouble. Yes. A lot of people have forgotten algebra. I agree with that. Okay, so we get this value right here. This, of course, if we decide we want to simplify it, is going to give us negative 2 less than or equal to 1 over 3x. And then this is going to be converted. We're going to be dividing by negative values, or no, not in this circumstance, we won't. This is going to end up becoming 6 is less than x, exactly like that. And so we know that y0 is going to be equal to x6. I actually probably should have put the x first, but whatever. So whenever x is equal to 6, y is going to be 0 in that situation. So what we want to do is we want to come in here and we want to graph these different guys. So we're going to put this guy right here, And then we can go to 3 over here, and that will go right here. And that's basically all the lines we have. Now, one thing that is extremely important here is to understand that whenever we are dealing with a non, if this was less than or equal, it would be a straight line, but it is not. It is a less than. So in search situations which we have that, I have to turn my little drawing device here. We're actually going to have to draw a dashed line, okay? So dashed line exactly like this. Why? Because it's not equal to in that circumstance. So let's put that right there. And then what we need to do is we have to say that where exactly, what values are going to be pertaining to our graph. Well, in this situation, that is going, since y is going to be less than, that means we need to shade underneath our line. So we can just go like this, and whoops, hit the wrong thing. Let's go grab that. Okay, I think I got it this time. So we're going to graph underneath our line. And this is the weird thing that we do whenever we are working with inequalities. And you get it. Like, you know, fill in that entire area. And there you got it. Okay? So that is the difference between working with multiple different... what software? I'm just using GoodNotes. That's all on an iPad. Nothing really complicated here. Okay, so now we get into system of equations. See, I told you it's going to get complicated pretty quick. Now, whenever you're trying to solve systems of equations, there's multiple different ways of doing it. Now, if your coefficients are opposite of each other, like we have here, so whoops, that's not the right pen. These are opposite each other. We got a positive 4 and a negative 4. In those situations, we can solve them using what is called, through the process of addition or subtraction. So how do we do it? It's very easy. Let's go. I keep saying very easy. We will say x, and this is a 4. Y is going to be equal to 5. And then x minus 4y. See, they cancel each other out. That's why we can do this. This is going to be negative 3. Exactly like that. And there's a straight line. So what does this do? Well, these guys cancel each other out. And then we have just quite simply 2x is equal to, and 5 minus 3 is equal to 2. So we know that x is going to be equal to 1. All right? Then what we need to do, after we know the value for x, we just need to solve for the other variable. So we can do that just by simply going 1 plus 4y equal to 5. And this means that 4y is going to be equal to 4. So that, of course, means that y is also equal to 1. And another thing that is extremely important is anytime you get an answer, oh, thank you. I'm very happy that you can see it. I think it's just a matter of practice. I do it all the time, so I'm just used to it. So, okay, so we have these two values. How do we check to make sure our answer is right? Well, we can go x plus 4y is equal to 5. And if we do that, we can just simply plug in these values and see if they come back correct. And that is going to be 4, whoops, no, I don't need the y there in that situation, is equal to 5. Okay, so 1 plus 4 equals 5, so we know that's right. And then we can also go x minus 4y is equal to negative 3. And of course, this works out to be 1 minus 4 is going to be equal to negative 3. And we know that, yes, indeed, that is also true. So we also know that what we did right here is going to work for us. Okay. Another way we can solve these types of systems of equations is graphically. So what we want to do here is we have y is equal to x plus 3, and y also is equal to negative 2x minus 6. Well, what do we want to do? We've done this calculation a couple times. we want to figure out what our y-intercept is. Well, let's just use this first equation right here. So if we give x a value of 0, well, we know our, let's do it like this, like an underscore like that. That means our y-intercept is going to be equal to 3. Pretty simple stuff. Now let's find the y-intercept for our other line. And that other line is going to be, again, put a 0 in there, -6. All right, pretty easy. So in this situation, we know that our slope is going to be equal to 1 over 1, or just quite simply 1. And we know that our slope for the second formula we have here is going to be equal to -2 over 1, using all of what we just covered before. And that means that we are going to have a point at 1 and 4, and another point right here at 1 and -8. So here it seems that they are going to intersect at -3 and 0. So we can say y is, if what we can actually do is go and graph all this stuff out. So let's use like an orange line here. So this is going to be approximately right here. Let's just plot the intercepts. That's all that I'm doing right now. And what do I want to do for the other one? Let's say I want to plot the other one at -6 like this. And we can just go in here and roughly draw in these lines. So I'm going to, well, let's plug this into the formula as well to give ourselves another point. It's quite simple. It's just going to go right there. So then we can just draw this line in right here, and then draw this line in. If we have -6, this means this is going to be -8. 1, 2, 3, 4, 5, 6, 7, 8. I'm just making sure that I'm plugging everything in the right position. So there goes that. This line is going to be right like this. And that is why we, whoops, never mind, didn't mean to do that. That means that these points are going to hit right here in the center area, and that means that our intersect is going to be roughly -3 and 0 if I drew better. So what we can do is we can actually come in here now and verify this intersection. So if we do so, let's use a different color. Y is equal to x plus 3, like that, and 0 is equal to -3 plus 3. So we know that, yes, indeed, that is going to work out. And likewise, we'll do it with the other formula, 2x plus, or this would be -6, apologize for that, -6, and if y is equal to 0, well, this is going to be -2 times -3 minus 6, and indeed 0 is indeed equal to 6 minus 6. So this is also true, and we have verified this graphically where these two formulas meet. All right, so pretty neat stuff. Can also solve with substitution. Yes, the Java tutorial is largely still accurate because Java hasn't changed as a core language for many, many years. That's okay to ask questions. Ask questions about anything. I don't care. That's why it's a live stream. Sorry, I lose my voice all the time, so I have to drink water. Oh, the video's frozen. Well, I apologize for that. I'm going to upload this to YouTube tomorrow. So I'll go and edit it and then upload the entire thing to YouTube. I just haven't figured out how to make. I think the problem is I'm not a Twitch partner, and that won't allow me to change my resolution on Twitch. I apologize for that for anybody that's having any issues. Hopefully we'll correct that someday. There's really nothing I can do. I just apologize for it. Okay, so what we want to do here is solve this system of equations, which just means find the values of x and y through the use of substitution. 1080p 60. Is that what I'm broadcasting at? I thought, yeah, I am broadcasting at 1080p. I sort of wanted to go between 720, and I definitely didn't want 4K, so I don't know. That was just the best decision I could make, because 720p ends up making everything look really blurry, and most of the algebra videos that are out there are kind of blurry, so I just wanted to make a non-blurry algebra video. Yeah, I apologize for that. Okay, so what we're going to do now is we will try to solve with substitution. Now, if one equation can easily be solved for one variable, you can substitute the result into your other equation. So in this circumstance, what I want to do is I want to solve this guy right here. X plus y is equal to 8. So I'm just going to go, this is going to become x plus 11x and minus 16 is equal to 8. And we're using all the stuff that I covered earlier in the video, just by adding and subtracting like terms and multiplying and dividing unlike terms. So this is going to be 16, of course, is equal to 8. 12x is going to be equal to 24. And then, of course, x is going to be equal to 2. Thank you very much for following. When I am... I could have put the parentheses in there. Yes, I'm just sort of skipping steps a little bit. Then, okay, so we have our value for x. What we want to do now is find y. So I'm just going to go and use this guy here instead. So in this circumstance, this is going to become y is equal to, and I just substitute in my known value for x. So this is going to be 11 times 2 minus 16. And y is going to be equal to 22 minus 16. And ultimately, y is going to be equal to 6. And if I want to verify that, yes, indeed, these are true, I can just go x plus y is equal to 8. Throw in those two values, and indeed, 2 plus 6 does equal 8. And then do the exact same thing for our other formula that we have here. So y is equal to 11x minus 16. And 6 is equal to 11 times 2 minus 16. And yes, indeed, 6 is going to be equal to 22 minus 16. Okay? So there you go. And that is how we solve a system equation with substitution. Another option we have available to us, and this is the last one, is, well, actually, that's not true. You can solve system equations using matrices very, very easy, but that's more of a linear algebra type of problem, which is the only subject in algebra I'm not going to cover today. Because I felt that it made more sense to just cover all the linear algebra and all the matrices stuff all in one separate video. Okay, so variable elimination. How's this one gonna work? Well, to use this technique, the coefficients of either the x or y terms must be opposite from each other. And so we have 2x plus y equal to 7, and x minus y is going to be equal to 2. Of course, I sort of covered this previously. 2x plus y is equal to 7. X minus y is going to be equal to 2. This goes and simplifies down so that we have 3x plus 0 is equal to 9, which means that x is going to be equal to 3. And then we substitute into our x value, where I stack the equations and add or that. Well, that's kind of what I'm doing right now with variable elimination. But you can only do them in situations in which, see how this is opposite this, okay? Y is the opposite of negative y. So that is that specific situation where you stack them and then just sort of add through. So now we'll take x minus y is equal to 2. Now we're using what we had over here, and we're plugging it into our other variable. This is going to simplify down to 3 minus y is equal to 2. And of course, y ends up being equal to 1. And then we could verify that that indeed is true, but I promise you that it is. Now let's take it up to another level. This is solving system of inequalities. Now it starts getting more complicated because we're going to have shaded areas in multiple different directions. Good point there, Barry Carter. You could most definitely multiply through the equations to make these different terms the opposite of each other. Most definitely, that is something else that you could most definitely do. Okay, so what I want to do here is I'm going to graph two linear inequalities, and then I'm going to go and shade in the region where the two of them overlap each other. So let's just go and solve them. So we have y is less than or equal to negative 3x1. Well, what are we going to do here? Well, we want to find our y-intercept by making x be equal to 0. Well, in that circumstance, the y-intercept is going to be equal to 1. And so we know that we have a point here at 1, and then 1 minus 3, like that. And, of course, that is going to be equal to 1, negative 2. And we could go and plot that out. I'm going to plot out everything all at one time, though, just to keep that more divided up. Y-intercept on our second is, again, going to be equal to negative 4. So we know that we'll have another point here at 2 and negative 5. And then, of course, we could go and we're going to have to go and perform a test to figure out where exactly we need to shade. But first, what I want to do is actually come in and draw in these individual lines. So let's make one of them orange and one of them like a cyan blue or something like that, and see if that works out good for our stuff. So we just put in our different intercept lines. Negative 2, so we're going to have a line like this, and in this circumstance we're using less than or equal to signs, so we know that we need to make these a straight filled line. So I'm just going to roughly draw that in right there. And then for our second one, let's make this, what color should I make this? I'm not really sure. I don't think white necessarily works really well for it. Let's try like a neon type of green here. I think that might work a little bit better. We got our other different intercepts here. So let's go down to negative 4 in this ballpark, and another one in roughly here. Now, in this circumstance, we're dealing with greater than, so that means quite simply that we are just going to use a dashed line. If I can do this, how do I draw this? I have to turn this in multiple different ways. So it's going to roughly be like this. Okay, so there you have your other dashed lines. Now I have to figure out exactly, oh, red. Yeah, I could have used red. All right. And so now what I need to do is actually figure out which way that I need to fill them. Do I need to fill to the right or to the left? Well, I'm just going to test with using the values of 0 and 0. So this means that we're going to ultimately end up getting 0 is less than or equal to 1 in this situation. Well, in those circumstances, I'm going to fill to the left. And then in the other one, I'm going to test it for 0 and 0 values for x and y. And if I do that, I get 0 is greater than negative 4. Well, that obviously is also going to be true. So we're going to put this like this. And in that circumstance, I'm going to fill right. Okay? And now I can go in here and actually fill these in. So I'm going to maybe use yellow in this circumstance. Whoops, didn't mean to do that. So I'm going to fill this in here, roughly. You get the point of what I'm trying to do. Maybe I'll try to do this a little bit neater so that you can see exactly where these two inequalities cross each other. So I'll just fill that area in right there. And then I will use the green for the other one, and let's see how that ends up working. That's going to be up in this vicinity. So there we are, and then you're going to see where exactly the inequalities are going to cover each other. And there goes neatness out the window. So it started off neat, but then we sort of lifted our pen, and you can see that where these two inequalities are going to cover each other is going to actually be in this vicinity right here. And it makes like a V shape up inside of there. Okay? So that's where our two inequalities that are going to work. All right? All right. So now let's move on to absolute value equations. Let's go get another pen, maybe get another drink of water. Yes. I could also say that y less than means lower and y greater means higher. Good. That's also a good way to explain that. Okay. Now, in the situation in which you're using absolute value equations, there are going to actually be two values because the value we take the absolute value of can be both a positive as well as a negative value. So that means to solve this, we're going to have to solve for both 3x minus 7 equal to a positive 8 and also 3x minus 7 equal to a negative 8 because that absolute value cancels them out. So this means that we're going to have 3x is equal to 15 and 3x is equal to negative 1, which means that our value for x can either be 5 or it could be equal to negative 1 over 3. Exactly like that. So let's try to get a little bit more complicated with our problem solving here. So we have 9 minus 3 times the absolute value of x plus 2 is equal to 15. Well, we can just go and cancel these coefficients. We're going to end up with 3, and absolute value of x plus 2 is going to be equal to negative 6. And then further simplify this down to x plus 2. Absolute value is going to be equal to negative 2. And also x plus 2 is equal to 2. And in this situation, we find that there is actually no solution because the absolute value can never be negative. As you can see right there, it just logically doesn't make sense. So that means that there is no solution. I wanted to try to get every type of answer also in creating this video. All right, so let's continue. Let's go and graph this guy. Sorry, it's getting a little bit distracting here. Let's go, and this is going to be 2 absolute value of x minus 7 minus 5 is less than or equal to negative 1. And we'll have 2, by simplifying, minus 7 is less than or equal to 4, which further simplifies down to x minus 7 is less than or equal to 2. And this is what would be considered to be a compound inequality. Let me see where I should write this. So this is going to be negative 2 less than or equal to x minus 7 less than or equal to 2, and also 5 less than or equal to x minus less than or equal to 9. And if we go and graph this, because we're dealing with equal signs, we are going to fill in both these dots. And we're going to have a dot right here, and then we're also going to have a dot right here, and we're actually going to fill in the line between two said dots. And there we are. Okay? What about... Yes, I could continue doing a whole bunch of these different things. If you really want me to figure out, solve some more problems with absolute values, but I kind of want to move on from this. All right, another important concept is what is called the fundamental theorem of arithmetic. Yes, it would be slightly different. If you really want me to solve any of those, want me to solve that problem, I will. I'm just trying to move through because I still have a ton of stuff that's also going here. I can go, what did you actually put here? I can go and solve that, and I'll put it in the notebook that I'll make available. It's free, the notebook. I'm just going to go and solve this problem, throw it inside of the notebook, and everybody can see that. I'll just have to put a note here so that I go and solve that. All right? Okay, so let's go to the fundamental theorem of arithmetic. What this says is that all natural numbers are either going to be, can either become, well, they either are prime numbers or they can be expressed as a product of prime numbers. And an example with this is, well, we can find the greatest common factor, but let's talk about prime factorization. Basically, in doing it, the prime values are going to be multiplied together to equal our final values. So how can we go and break 20 into a bunch of prime numbers? Well, one thing you can do is just simply say, well, what can you do with a prime number in regards to 20? You can divide it by 2. All right, that gives you 10. What can you do with that? Well, can you do something with 2? Yes. Let's just throw 2 in there. Okay, and then finally you end up with 5. And of course, 2 times 2 times 5 is going to be equal to 20. This is a very important concept. Okay, so you can do exactly the same thing with 48. Maybe I want to write this out so that we can see it. Well, 48, can I divide it by 2? Yes, I tell my daughter this when I was teaching her this exact same thing. I'm going to keep it as simple as humanly possible. Well, you can turn a 48 into 2 times 24. Okay, so what you do is you take this 2 over here and you throw it inside of there, and then you can continue to basically divide by 2 as long as you can divide by 2 until you end up with having to multiply times another different number, or divide by a different number is what I should actually say. And this ultimately is going to end up giving you 2 to the power of 4 times 3. Okay? And that is how prime factorization works. So let's talk about how that can be used to be able to find what is called the greatest common factor. It's the same exact process. All right, so what we're going to do with finding the greatest common factor is you just list all the prime factors of each number, multiply those factors that are in common. Let me just show you an example because it makes more sense this way. So I'm going to say that I have 24. So we have 24 and 36. What is the greatest common factor between them? So we have 24 and 36. Now remember, all you need to do is keep it simple. Can you divide 24 by 2? Yes. Is 2 a prime? Yes. So keep it simple there. Then you end up with 12. Can you divide that by 2? Yes, you can. And you just continue doing this until you basically have 2 times 2 times 2 times 3 is going to be equal to 12. All right? It's very simple. All right. So again, 36. Can you divide by 3? I'm gonna switch it up this time. I'm gonna do a different number. So you have 3. And then you just continue dividing and dividing and dividing with prime values until you don't have any more division to go about. Okay, so then after you do all that, what you want to do is just highlight those values that are in common. So we have 2, 2, 2, and 3, 3, 3, 2, and 2. Well, these are in common. These are in common. This is in common with that. So what does that tell you? Well, that tells you that the greatest common factor in this circumstance is going to be equal to 2 times 2 times 3. So greatest common factor between the values of 24 and 36 is going to be equal to 12. All right? Let's do a more complicated one, like 54 and 72. Again, we can go and just list 54. And, of course, you're going to ask yourself, can you divide by 2? Yes, you can. And then you're just going to continue dividing by either 2s or 3s or 5s. That normally suffices until you're able to create 54 with just a bunch of prime numbers multiplied times each other. Do the same thing with 72. 72, this is going to be 2 times to the power of 36. If I just want to write this out, which is going to be equal to 2 and 18, like this, which is going to be equal to 2 and 2 and 2 and 9, like that. And then we have to go and recreate the 9, and what we're going to end up with is 2 times 2 times 2 times 3 times 3, and then we go and we find those values that are in common once again. So we have 1, 2 here, we have a 2 here, we have a 3, a 3, a 3, a 3, and that is going to give us our greatest common factor. For those two values, greatest common factor is going to be equal to 18 in that situation. All right. No, this is not a Java design pattern video. I made that video series forever ago. I'm surprised it's still hot. I mean, yes, I will be getting into later on, further down the tutorial, I'll be covering things like a lot more complicated topics like that. Yes, logarithms and Euler's number and all that stuff. So this brings us to polynomials. What are polynomials? They are going to be equations in which you have 2, 3, or more different terms inside of them. So how do you simplify down a polynomial? Well, anytime you're working with exponents like this and you want to combine them, all you need to do is take all of the like terms that we have. Let me use a different color here. I use the same color every single time. What am I doing? All right, let's go. There we are. And you're just going to take all these different values and you're going to add them together. And this rule right here tells us that. If we have a variable with an exponent and we multiply it times another variable with an exponent with a like variable term, we just add the exponent values. So this becomes x to the 15th, y to the 17th. Here is another rule. So these are the sort, remember I said algebra is basically just memorizing some rules. Well, those are the rules. You can probably fit all the algebra rules that exist on the front and the back of one piece of paper. So just write all of them down and you got it. Okay, so how are we going to simplify this? Well, it just says if the exponents are you have an exponent in the numerator and denominator with a common variable term, well, you can simplify them by subtracting those values. So if you go and simplify them, let's see if I can draw a straight line. Well, this will help me with it. There we go. This is just simply if we go and we have w to the power of 10, w to the power of 2, well, we're going to subtract this value, this 2 here, from this one up here, and what does that leave us with? Well, it leaves us with w to the power of 8, and then we can do the same, subtract the 4 from the x. This is going to be x squared. In the circumstance in which we have a larger exponent on the bottom versus the top, we can still subtract this from this guy right here. This means we're going to end up having y to the 4th, and then likewise 7 to the power of 2. Can I subtract just the end, or delete just the end? Yes, I can. All right, so those are two rules and how they can be used to. Yeah, I'm sort of skipping over every possible way of solving problems if I can solve them well enough using just one concept. So yeah, that's it's sort of a choice I had to make, just to keep this video, which is already going to be very long, a little bit shorter. Guess what? We got another rule, and here's a whole bunch more rules. So we got some more rules here and another rule over here. And with the power of these rules, you're going to be able to solve further and further more complicated problems. What does this mean? It just means you have a negative exponent. You're going to be able to either eliminate it altogether, or like we did in this circumstance, or you're going to change the exponent to a positive and you're going to flip the fraction. So let's say that I want to come in here and, using all of these awesome rules, go here, like these are all rules also. So there's another rule, another rule, another rule, another rule. Okay, there's not that many rules. It just seems like there's a lot of rules because normally whenever you're learning algebra, they hit you with all the rules all at one time and you're like, oh, there's so many rules. But then whenever you actually list out all the rules, there's not that many. It just seems like they normally come in groups. So how exactly are we going to go and simplify 4x over 7y to the third to the negative 2 power? Well, we're going to flip the equation, and then we are going to square all of the results inside of that. And if we do so, this is going to end up being converted into 49y to the sixth. Okay, so this guy right here and this right here, whenever you put those two exponents together, rather than add them together, you're going to multiply them. All right, so this is going to be to this, and because we flipped them, we flipped the equation, this negative sign goes away. So it's very simple in that regards. And then you also square everything else, and that is how you simplify that and solve that. Now you can also go and do the same with cubes. And if you do this, this is going to end up being equal to x to the power of 6, y to the 18th, and straight line, 9x to the negative 2, y to the 10th, which is going to then further simplify down to 9y to the 8th over x to the 4th. Thank you very much, Trump Daddy. I greatly appreciate it. Greatly appreciate it. All right, let's get into more stuff. Radical expressions. What do we want to do here? So, whenever we're talking about radical expressions, this is when things start getting more complicated. Well, one thing you need to understand is the concept of the perfect square. And that's just simply something multiplied times itself. So it could be something as simple as 36 is equal to 6 times 6, all right? X to the 4th is exactly the same as x squared squared. Y to the 8th is going to be equal to y to the 4th squared, okay? Very important concept, because it's going to dramatically help you in regards to solving problems like this. So if I wanted to rewrite this problem right here, and this is called a radical, as the arrow already displays. This is your index, and then your radicand is the value that is inside of there. Okay, so just some more jargon. Well, thank you very much. Wow, thank you very much, Trump Daddy. I greatly appreciate that. That is ridiculously awesome. So thank you so much. I mean, wow, thanks. I'm so happy that my design patterns videos have helped so many people. That's one of the most, I think that's probably the video I did or video series that I did that I think people got the most value out of. So I greatly appreciate that. Here, let's see. I'm going to move your thing down here. All right. Thank you very much. I mean it. I super appreciate it. Mainly just because I just like the idea that people are finding value in what I'm doing. That's all. Okay. So how can we go and solve this using, or rewrite this using perfect squares? Quite simple. Let's just go and convert this into 36 times 2 times, this is going to end up dividing or breaking up this x to the power of 5, which is going to be x squared, times x squared times x times y to the 4th times y to the 4th. All right, and throw in our square root indicator inside of here. And then we can go and further break this down to 6 squared times 2 times x squared times x times y to the power of 4 squared. All right, see how they're all breaking down? And then we can further then simplify anything that's squared, like that, like that, like that, can be pulled outside of the radical expression, and you get 6x squared y to the power of 4. And then these two guys that are left inside of here trapped, well, you just leave those inside of there. Exactly like that. All right? And that is how you can simplify this rather complex radical expression into it's simplified form, exactly like that. Let's go and solve some more. In this situation, we are going to be working with our cubes. So again, we want to further break down everything into our cube roots. Let's go and use a different color here just to break this up. Okay, so this is going to be equal to -2 and cubed. Whoops. Let's go. Use so many 3's and I can't draw a 3. There's a 3. And again, for our next value, this is going to be x squared cubed. See, we're just breaking down everything in that. X, now that, you know, is going to get trapped inside of here if we can't get rid of it. Y cubed. And here's our additional awesome rules that we need to memorize. Then we'll have y squared and z squared. We can't do anything with it. And then we just take everything that we were able to cube, all of these guys, throw them outside to simplify this. So you got -2 x squared y to, yeah, so this would end up being just simply y. And then we're going to have all the stuff that was trapped. So x and y squared, z squared, and like this. And then don't forget to put the cube root symbol right underneath of it. So awesome stuff. Okay, now let's say that we want to now subtract two radical expressions. Well, in this circumstance, are we going to find the cubes of all of these, or are we going to find the perfect squares? That's the sort of stuff you have to ask yourself. Well, we know based off of what we're looking at that we're going to be able to find perfect squares. And we also know based off of all these rules over here how we're going to be able to operate with these guys. So let's just break it down into perfect squares. So this is going to end up being 4 times 7 x, y, and like this. So we'll draw that in. There, it looks nice and clean. Minus and 4 times 7 x, y, and again, there they are. I should probably have made a little bit more space here for myself so that I didn't have to write on top of myself. Let's go and move this down here a little bit more and bring this over here. This is going to further simplify then to 2 times 2 square root of 7xy, the two terms we can't work with, minus and 2 and 7xy, which is going to further come down to 4 and square root of 7xy minus 2 square root of 7xy. Exactly like that. And we are going to, because we have like expressions here, this is actually going to further be able to simplify down to, we can just subtract the 2 from it and get 2 square root of 7xy. So it ended up working out really nicely for us. And how can we go and rewrite this radical expression? Well, we can just go and put the cube root of square root, let's bring this right here. So this guy is actually the same as saying what I'm going to draw right here. So this whole entire term squared. So anytime you see this, you know you can put it into this specific format. And then we just need to go through and break it down into cubes. So this is going to be 5 to the power of 3 times 2, and like this, and just keep it very simple. And this is going to be squared, and this is also, of course, going to be, let's just take the 5 out of there, cube root like this, and the 2 is left inside of here like this, and this is ultimately going to be equal to 25 and cube root of 4. Okay? And that is because this guy right here is going to go and be multiplied times these different terms to get that final answer. Okay, that's perfectly fine. All right, let's move on to some additional ones. What else do we have here? All right, so how are we going to simplify this? Well, it's just simply going to be 3 times 3 times 3 times 3, which of course means that this is going to be equal to 3. All right, so I broke those down into 4 individual equal parts, and that gives us our final answer of 3. Let's go and do the same thing. Likewise, for this guy, this is going to end up being equal to negative 8. For this, it's going to end up being equal to 10, because of course 10 times 10 times 10 is going to be equal to 1,000. Book smart. Then if we go and try to work this guy out, we're going to end up getting a similar type of format where we're just going to try to find everything that is a cube, put it inside of here, and this will be x squared like that. And then this is going to end up, we can take this out because those two cancel each other out, and we'll end up with x squared and the cube root, and inside of here everything that's left behind, which is just the x squared. More complicated concept here. Let's go and try to solve this guy. So this is going to, again, basically be solved in exactly the same way. We're going to break it down into parts so that we can cancel things out. So this is going to be x to the 4th and x to the 3rd, and then times, this is going to be able to simplify down to y to the 5th and 4. And then, of course, this is all based off of these other different rules that we have inside of here. And this is going to be z squared to the power of 4 times z to the power of 3. And then this is going to, once again, just be everything that is inside that we have been able to take to the power of 4 is going to be thrown out of this guy. And then we are going to leave everything that is left inside of it. And I think you kind of got the point. I don't think I need to go and write any more of this stuff out, do I? I don't need to solve that. Okay, so let's move on to another radical expression problem here. The reason why I'm spending so much time with radical expressions is this was one of the concepts that a lot of people really struggle with. So if you're wondering why, that is the reason why. Again, we're using these rules back here. You might want to write them down to solve some of these different problems. But basically, if we have x to the 15th, this is going to be equal to the same as saying, whoops, what am I doing here? 3 or 15 divided by 3, which is going to give us a value of 5, and you're going to do that for all the other different values as well. Let's move this out of here so that I have a little bit more room. Let's move it down here. I think that might be enough. And let's do the same. Y to the 5th is going to be, and let's go 3 divided by, or 5 divided by that, and that's going to be 1, which is going to give us a remainder of 2, and z to the 6th is going to be 6 divided by 3, which of course is 2. And what we want to do here is separate the factors raised to the power of 3 on the left. So let's put this in a different color. So this is going to be x to the 5th like this. So I'm converting all of these different values. This is going to be y to the 1, 3 times y squared times z squared to the power of 3, like that. And then this is ultimately going to give us, we just take out everything that's different. So I guess I should put in this cube root part right here. So there's cube root. And if we take out everything that is a cube, this gives us a final answer here of x to the power of 5, y, z squared. And the only value that's going to be left inside of here is our square, like that. And there you are. So that is how we're able to further simplify those down. Let's do another one. In this situation, we're going to be working with perfect squares. I'm sort of repeating myself just to give you more input. Found it helpful to express radicals as fractional exponents. Most definitely. I think I cover that also. Yeah, I thought I covered this also later on as we continue on here. Let's see. I think I kind of remember every single thing I put inside here. This is a really big video. So in this situation, what I want to do is to solve this problem, is what I'm working on, is to find products of perfect squares. Again, just like we did in the previous example that we have here. So we're going to have 2 squared to the 5 there, or times 5, which is going to be a product with a perfect square. Again, x9 is going to, again, you're going to divide 2 into 9 and get a value of 4 with a remainder of 1. And then y to the third, we're going to divide 2 by 3, which is going to give us a remainder of 1. So let's just go and figure it out from this point. All right, so this is kind of getting a little bit busy. Let's go and delete all this stuff so that I have a little bit more room to work with everything, because I'm sort of scrunching everything together, and that is not a good thing. All right, so let me write out what I was thinking. Okay, so we're going to y to the third, and this is going to be 2 divided by 3, and this is going to, of course, give us a remainder of 1 also. And again, we're just finding perfect squares here, and I'm just writing all that out just so you can see the thought process that I'm taking. So this is going to be 2 squared times 5 times x to the power of 4 squared times, and we have a leftover x inside of here, and this is going to be y squared and y to the power of 1. And then this ultimately, if we take out all of our different squared values, is going to leave us with 2. The 2 comes out, of course, and this is coming out, and all the other different ones. So this gives us 2x to the power of 4, like that. And y, the y also is going to end up coming out, this y right here, because it is also squared. And that just leaves us with the values that cannot be put into a squared form, which gives us 5x to the y. All right. All right. Another concept that's important to understand is that you can only add and subtract whenever the indices and the radicands are equal. So, of course, this guy right here is just simply going to be simplified down to 7 to the square root of x. And let's go and get rid of this, and it will solve our final little problem here. Let's grab it and throw it over here. Can you see whenever I do that? Oh yeah, you can. All right, so there we are. And what I want to do here is I want to use exponents to eliminate the radical. So I'm just going to simplify this down just by converting it into x plus 16, and I'm going to take the square, or I'm going to square the outside value. Okay, so sometimes it works better to get rid of this. We just square the 5, so it becomes 25, and it makes our problems considerably easier, and we find that x is going to be equal to 9. All right, what else do we got? Let's continue. Another concept that's important is the concept of completing the square. Now, an expression is going to be a perfect square if it is equal to 2 expressions multiplied by themselves. So we have x minus 4 times x minus 4. Well, what are we going to do? This also brings in the concept of FOIL. And what FOIL says, it's just one of those mnemonics. What we're going to do is we're going to get the first, the outer, the inner, and the last. So how we're going to solve this is we're going to take the first times the first, so x times x is going to be equal to x squared. And then we're going to take the outer. Negative 4 times x is going to be equal to negative 4x. Negative 4 times x is negative 4x. And then the outer, which is going to end up being equal to plus 16, which we then can just simplify to x squared minus 8x plus 16. All right, so let's go and do that with all the other ones. So we got 2. This is 2y squared. This is just the basics of FOIL. Negative 2y. And did I do that in the right order? No, I didn't. I didn't do it in the right order. I was just talking about FOIL, and then I messed it up. Okay, so this is going to be 3y minus 2y minus 3. Like this. And then, of course, this is going to end up being equal to 2y squared plus y minus 3. All right. And let's do one more. It doesn't really matter how big these expressions are. In this circumstance, we're going to take the first and multiply it towards all these other different values. So what this is going to do for you is you're going to get 2x squared plus 10xy minus 2x minus xy minus 5y squared plus y. And if we further simplify that down, we're going to get 2x squared plus 9xy just by combining the like terms, minus 5y to the squared minus 2x plus y. All right, and there we go. Now we're getting into factoring trinomials. Even more complicated. What happened to my box? Here, let's move it up here. Oh, that didn't work. Oh, my box got moved. Here, let me move it back. There we are. That looks more professional. Okay, so factoring trinomials. You guys should have told me. It should have said, hey, your box is missing. Okay, so how do we factor trinomials? Boy, I really combine these a lot. You can see here an example of perfect cubes and also a repeat of the exponent rule in regards to how they can be combined. So in regards to factoring the trinomial, this guy right here, what I want to do is I want to multiply what I want to be able to do is I want to be able to multiply values for our center values that are going to be equal to 12 and then that are also going to be able to be added together to give us a value of 8. And that is quite simple also. So we got this. This is basically here just to give us our x squared plus. And what values are we going to be able to multiply together to get a value of 12 that are then going to be able to be added together to give us a value of 8? Well, 2 and 6 work. So we're just going to turn this into 2. We're going to turn this into an 8. And that is how we can factor our trinomials. Now, for this 3x squared plus 9x minus 3, you're going to do exactly the same thing. For these two values that you're trying to find, every single time you want to ask yourself, what do I multiply times to get our final value, which was this value? And then to get this guy right here, you say, what two values also can I add together that are going to be equal to 8? All right, you just say that over and over again. Well, in this situation, it's actually going to need, you're going to need to divide by 3 to simplify this. So we'll just convert this into 3x squared plus 3x minus 10, of course. And then we can go and factor this trinomial on the right side. So this is going to end up being equal to 3 times x plus 5 and minus 2. Because if we multiply 5 times negative 2, we get negative 10. And if we subtract negative 2 from 5, we get 3. All right? hopefully that is useful. I'm going to do more of these trinomials because they seem to confuse people a lot. Now for this one, let's go and delete this so that I have more room to actually be able to write so things don't get all pushed up next to each other. Okay, so in this situation, we can't do that because we don't have a greatest common factor. So what are we going to do in those situations? Well, I'm going to... sorry, I deleted it. Do you want me to go back and bring up what I had here? This is going to be equal to... Yeah. Oh, you know what? You are indeed... Yes, this should have been 6. I apologize for that little error. This is going to be x plus 2 plus 6. Yes, you are indeed correct. Thank you for catching that. Maybe I shouldn't be deleting these. Maybe I should just be moving them around on the screen here a little bit. You are indeed correct. I made that error. Okay, so let's go and figure this one out. So we don't have, see, before we could take the 3 out. We can't do that with 3, 5, and 12. So how on earth are we going to be able to actually solve this problem? It's kind of complicated. But what we can do is we can go and convert this value that we have right here into, let's go and convert this into, whoops, why did I use so many 3's? I don't know why, but 3 is like the only number that I have trouble working with. We can go and get this x out, or the 3x out of this. So this is going to end up being equal to 3x squared plus 9x minus 4x minus 12. See, we can break them apart into individual pieces that we can get a greatest common factor for. And then we'll be able to just go and get the 3x out of this, and that leaves us with 3 or x plus 3 like that, and minus 4x plus 3. And then this is going to further simplify down. We take this part and this part, throw those between parentheses, and get 3x minus 4 and x plus 3. All right, so multiple different ways if you have a greatest common factor, and ways of doing it if you do not have a greatest common factor. Yeah, I'm just reading an old comment. Got confused there for a second. Okay, so how do we go and solve the next one? This guy right here. Well, in this situation, we can use our exponent rule to make things a lot more simple. So we can convert this into 3 to the power of 3, x to the third, and this will be plus 2 squared, y to the third, also like that. And this is going to, with the exponent rule, give us 3x to the power of 3 plus 2y to the power of 3. And then we can go and work these out to then give us 3x plus 2y, and multiply all that out to give us 9x squared minus 6xy plus 4y squared. And there we go. Another solution is, let's just go move these around a little bit so that I can actually work with these a little bit better. So I'm going to go get this guy and grab it and move it up a little bit so I have more room to write with my final problem here. So move this guy up here and grab this. Okay, so for this problem that we're trying to solve, what we want to do is create two binomials with a greatest common factor like we did previously. And I'm just going to work this out. And this is going to give us 2 again, we're going and getting out and trying to simplify this. So we're going to take out the common amounts, which would be 2x squared, and that's going to leave us with x minus 3x, like that, minus, and take out the common value again, which is going to be 5x minus 3 in this situation. And this is going to simplify down further. Can you even see this at this point? Let's move it over here, which is going to be equal to 2x squared minus 5 and x minus 3x. All right. So I think that's enough of those. Why don't we now talk about synthetic division and how that can make our lives considerably better. All right, I'm back. Ugh, this is exhausting. It's like taking the world's biggest algebra test. And my iPad keeps shutting itself off. It's like, enough already. Oh. Okay. So what we're doing here is we're going to be dividing by some polynomials. I'm going to show you how to do it the one way, and then I'm going to show you how to do it using synthetic division. With synthetic division, you can divide by a linear binomial. Let me phrase that differently. You can use synthetic division if you are dividing by a linear binomial, but I'm going to show you how to do this the long way and the short way so that you know both ways. Okay. What's important here is we're just going to convert this. Make sure I'm using a good color. Okay, so this is going to be x squared, but we do not have an x value. So in that situation, you just put 0x. Okay, so that solves that. Plus 4. Okay, so we got this right here. Then we're going to have to do likewise with all of the missing terms for this. So we have x to the 4th, but we don't have x to the 3rd, x to the squared, and so on. So we're going to have to work those in as well. So this is going to be x to the 4th plus 0. If you don't have a term, you just throw it in there. Just checking to make sure I still am, you can still hear my voice. X squared, and then plus 7x minus 2. Okay, let's go and let's move this out of here altogether, because this can get kind of complicated, so I want to make sure that it's understandable. Okay, so we just draw that in there. Hopefully it makes the line straight, and it did. All right. So we got this. How are we going to be able to work this out? Well, we just work with the very first term that we have. So what do we need to multiply times x squared to give us 2x to the power of 4? Well, we multiply it times 2x squared. And then we go and multiply this value times all of these individual values to get all our other values. So this ends up being equal to 2x to the 4th minus 0x to the 3rd minus 8x squared. And then we draw a line underneath of it and we work this out. And this is ultimately, these cancel out. The first two terms are going to cancel each other out, and this gives us 8x squared plus, and we bring all our other terms down because we have 3 over here, so we have to have 3 over on the other side. So 7x and 2. And what do we need to multiply times x squared to give us a 8x squared? Well, it's going to be a positive 8x squared. So we're going to multiply that times negative 8. And this gives us 8x squared. And then if we continue to work on, this is going to give us 0x. And 4 times the negative 8 is going to end up being equal to positive 32. So based off of all of this, we then finally get a remainder of 7x plus 30. And how we would work this out is this is going to end up being equal to 2x squared minus 8 plus, and you'll get the 7x squared plus 3, or 7x plus 3 divided by x squared plus 4. Okay, so that is how we're able to basically work through this division we have here. But like I said, you're going to also be able to use synthetic division to solve these problems in a more simplistic form. So what we need to do that when we have that situation in this other problem we have here, I think it's okay to erase this because I think you get the concept. We're just basically, what values do we need to multiply to get the said values, and then we are just continuing to add and subtract the said values. Well, what we're going to do is we need to list the coefficients of the dividend and the opposite of our divisor. So we're going to convert this into 2x plus, well, let's just go and get rid of this. All right. Whoops. I didn't mean to do that. Okay. So what we're going to do is we're going to take this 4 that we have right here. We're going to get the opposite of that. So it's a negative 4. So we're going to use a positive 4. And we're going to put this inside of a little box here, just the way that it's all set up. Then we're going to take our different coefficients. So we got our 2, our 6, and our negative 8. We're going to then draw a line right like this. There it is. We're going to take this first value, which is 2. We're going to drop that through. And then what we need to do is multiply our 4 times our 2, which is going to give us a value of 8. If we go and add those through, we get a value of 14. Once again, we're going to take the 4 times that 14. We're going to get a 56. And if we subtract 8 from 56, we get a value of 48. And what this means is if we go and perform this division using synthetic division, that this is ultimately going to give us a value of 2x plus 14 plus, and we have our remainder, which is the last guy we have here. We throw x minus 4 right here and the 48 on top. And that is synthetic division and how it works. Quadratic formula. Here is our quadratic formula that we have here. Now you're going to be able to solve equations of, did I write that down? I did not write that down. Basically, you're going to be able to solve equations of the form ax squared plus bx plus c equal to 0 using this wonderful formula called the quadratic formula. So let's go and just plug all the values into the formula and figure out how it works. So this is going to end up being equal to x1. You're going to have 2 values here because we're using plus and minus. So this is going to be equal to ultimately, do you need me to? I'll work it out. Why not? So let's go. Let's delete this and then let's rewrite this. Okay, so this is going to be negative 19 plus or minus 19 squared and minus 4 times 6 times 15, and let's get the square root of that value and put a line underneath of it. Then we go and transpose all of those different values into the A, B, and C spots. This means that we're going to get one value, x1, is going to be negative 19 plus 1 divided by 12 in that that's going to work. And then this is ultimately going to end up being equal to negative 3 over 2. And then we'll have a second version, again, because of this plus and negative that we have here. And that's going to be negative 19, just like we did before, minus 1 divided by, and again, 12, which is going to simplify down to 5 over 3. So, fairly simple way of solving those problems as well. And this brings us to rational expressions. They're called rational expressions because they have a fraction in them. So, what do we want to do to be able to solve these guys? Well, what we're going to do is we're going to find the least common multiplier of 16y, z, because remember, we're dealing with fractions, so the denominator has to be equal. So it's going to be z and 12x. So we're just going to worry about the numbers themselves. So we talked about finding the least common multiplier before. What are we going to do for 16? That's going to be 2 times 2 times 2 times 2. And for 12, that is going to be equal to 2 times 2 times 3. And we go and combine these terms to find our least common multiplier. So that multiplier is going to be these values and these values all multiplied together. So this is going to be 2 times 2 times 2 times 2 times 3. And that's going to be equal to 48. All right. And now that we have that, we know that our divisor is going to be equal to 48x, y, and z. Can't do anything with those variables other than that. And now what we need to do is to get our denominator the same for each one of them, we need to figure out what we need to multiply times the numerator to make the denominators equal. So, let's use a different color. We're going to take x squared and 16y, and we're going to have to multiply that times 3xz over 3xz to give us a final value of 3x to the third z. Whoops, there we are. And again, our common denominator, which is going to be 48x, y, and z. This is starting to get a little bit more complicated, isn't it? Okay, so now we need to do the same thing for y over z. So y over z is going to get 48xy. We're actually going to have to, or xyz, I mean, we're going to have to multiply the numerator and the denominator by 48xy, 48xy, and this is going to give us a final value of 48xy squared over 48x and y and z, again from over here. And we're going to do exactly the same thing for our 5z cubed and over to 12x. What do we need to multiply times that to give us 48xy on the bottom? Well, we need to multiply it times 4yz and 4yz. And that is going to give us 48xyz on the top. And then we'll get 20yz to the fourth. And now that we have all of those common values across all of them, then we can basically just copy and paste these. So let's just grab this one and drop it over there, and this one and drop it over here. So we'll throw that there. This is going to be minus, and then, I'll just write it in, why not, plus 20yz to the fourth, all with the common denominator of 48x, y, and z. And there you go. That is how you simplify that rational expression. And do I need to do another one? Well, this is kind of something that's sort of interesting, so I'm going to cover this problem because you solve it in a different way. Slightly different way. All right. So for this, what we're going to do, again, we need to find the least common multiplier for our denominators once again. So how are we going to do this? Well, I'm going to take 6x squared and minus 54. And because I talked about previously about how we can go and break down trinomials into individual pieces, this is actually going to convert into x minus 3, x plus 3. Okay? Everything's building upon itself. And likewise, x squared plus x plus, minus 6 is going to convert into x plus 3, x plus, or x minus 2, So minus 2, exactly like that. And what we're going to be able to do now is to combine both of these and create a common denominator. Let's make this in orange instead. So we'll get 6x minus 3, x plus 3, x minus 2. And that is going to be our denominator in that situation. And then what we need to do is multiply the numerators of each of the individual parts to get our final denominator. So it gets a little tiny bit complicated. X to the 4th. And what do we're going to have 6x squared minus 54 times, to get that value, we need to multiply times x squared over x squared to give us a value of x squared minus 6x plus 8. And I'm not going to write in that denominator, the denominator, because it's so extremely big. And in the circumstance in which we have 2x minus 3, I am going to, again, this will be multiplied x squared plus x minus 6 and times, this will be negative 6x and 3, like this. And this is going to give us a final value of negative 6 2x squared minus 9x plus 9. And if we go and add these values and that value together, we get a final answer of negative 11x squared plus 48x minus 46, all over, exactly like that, this guy that we went and created right up here that I'm going to steal and put down there instead of writing all that out. All right. I say, sometimes I say squared when it's supposed to be minus. Okay, sorry about that. Sorry that. Hopefully that's not confusing. This is just a lot of information to be covering in one video. I'm doing my best. Okay. Now we're going to be multiplying. So what can we do here? Well, we can go and further simplify these just by going and getting the cubes and multiplying 2 times 2 times 2 and so forth and so on. So we're going to convert this into 8x to the 6th, just to simplify and eliminate those exponents, which can become quite confusing. And this would then end up, because this is negative, we need to flip this fraction. So this is going to give us z to the 4th and 16y to the 6th. And then we just multiply through. So this is going to be 8x squared, z to the 4th, and y to the 3rd. 16y6, and then that is going to be able to be simplified further down from that point onwards, if we wanted to factor out the 8. In regards to 4x minus 3, this is going to be able, that is a really complicated one. Let's go and just move this up here a little bit so that I have more room to write with this. This is going to be able to be solved. Well, this is actually supposed to be 4x minus 3x minus 8 is equal to 4x minus 3. I actually copied the problem down wrong. So how do we solve a problem like this? Well, what we're going to do is we are going to cross multiply these two individual fractions. So this is going to end up being equal to, I guess I should draw like an arrow instead because otherwise it'll cause confusion. If we cross multiply these values, we're going to end up with 4x squared minus 19x plus 12 is going to be equal to, because the rule of cross multiplication is those values would be equal, is 4x squared plus 29x minus 24. And what we can do here is subtract out our 12, which is going to be 4x squared minus 19x, which is equal to 4x squared plus 29x minus 12. And then it's going to be further simplified down to 48x is equal to negative 36. And if we divide those values and simplify, we get a value of for x of being equal to 3 over 4. All right. Wow. Yes, this is all going to be uploaded onto YouTube tomorrow. I'll edit out the pauses and stuff like that. Now we're talking about functions. We still got logarithms and ranges and all this other stuff after this. Okay, it's just simply a function is just simply an equation that for each one input, it's going to provide exactly one output. Now, some of the ideas that people get a little bit confused about is domain, codomain, and range. I think it's better to, okay, so let's say we have x and we have our function, which is just simply x squared. This is how range and domain and all those other different things play into it. Now, your domain is just going to be the set of values that a function can accept. So it could accept 1, 2, 3, 4. It can accept any of these values. The codomain is going to be what potentially could come out of it. So 1, 2, 3, and 4, and 5. So what exactly is the range? Well, the range is the set of actual outputs. So the range, the difference between the codomain and the range is the range are actual values that could come out, all right, whenever you are squaring the values of x. So this is going to be the domain, and this is the codomain, and then the range are the actual values. That confuses some people sometime, and hopefully that is not confusing anymore. Another drink. Now, remember I said that a function is an equation that for every input there is exactly one output. Well, that is exactly why this guy right here is not a function. We have a thing called the vertical line test. And what that means is if you can draw a line and touch to a vertical line, and you can touch more than one part in your plot for the function, that means that it is not a function. So this function that we have right here indeed does not pass the vertical line test and hence is not a function. So how exactly do we find the range? Well, this is a function we have right here, and what we're going to do is we are just simply going to simplify this equation. So let's say, I don't know if you guys like the blue color more or the orange color. I'm going to stick with the blue. So what we have here is I can say x squared is equal to y plus 1. And that means that x is going to be equal to the square root of y plus 1. And that means that y is going to be equal to, and here is our notation that we learned earlier, 1 to infinity. All right, and remember, if it's undefined, you have to use a parentheses instead of the square bracket. And you can't, because basically you can't include anything that isn't a real number. All right, so let's move on to some function problems. So, is this guy right here a valid function? Well, let's take a look at it. We said for every one input, there has to be exactly one output. Well, in here we have -2 as an input, and it gives one output. Here we have 4 as an input, it gives 2. Here we get 4 and we get 3. Uh-oh, that's a problem. For the same input, we are not getting the same outputs, as we can see right there. So in that situation, you would know that no, indeed, this does not qualify as a function because you're getting 2 outputs from that one input. Let's move on to the next one. So if we have a value fx, this is just a symbol for a function. So we have this guy right here, and we have this other function g. How exactly would we model out fg to the fourth? Well, we would just convert this guy. This would end up being x squared plus 2, like that, times 2x plus 4, exactly like that. And then we could just fill in those values to get our simplified answer, which is going to end up being equal to 16 plus 2 times 8 plus 4. And if we work all of those out, that's going to give us 18 times 12, and that gives us a final answer of 216. All right, what else do we got here? Getting a little messy. Well, here we have our other formula. Let's say, yeah, this is best going to be solved with this quadratic equation that we have here. And that's the reason why we have our handy-dandy quadratic equation. So this is going to be converted down into x squared plus x minus 6 is equal to 0. We'll use our quadratic, so we'll say this is x is going to be equal to -1 plus or minus at this will be 1 squared and minus 4 times 1 times -6. We're going to go and get the square root of that value. This is going to end up being equal to 2 times 1, which is 2 obviously, which is going to then give us a value of -1 plus or minus and 1 plus 24 over 2. And of course we have 2 values of x in this circumstance, which are going to be -1 plus 5 divided by 2, which is going to give us a value of, it's going to be 4 divided by 2, which is going to give us a value of 2. And then our second value, where we're using a negative value, is going to end up being equal to -1 minus 5 divided by 2, which is going to be equal to -6 divided by 2, which is going to give us a value of -3. All right, so that's how we solve those ones. Let's move on. Okay, so if you ever see this symbol here, this guy right here, what this means is it's read as f composed with g of x. And it is, let's see, basically going to be equal to f g of x. Exactly like that. All right, so how exactly do we solve problems like this? Well, this is going to be converted into 2x plus 6 squared plus 4. exactly like that. And then if we go and work these out, this is going to be 4x squared plus 12x plus 12x plus 36 plus 4. And, of course, we can simplify this down to 4x squared plus 24x plus 36 and 40 plus 40. All right, another one. So, yes. Now we got inverse functions. Now, two functions are going to be inverses in those situations in which you compose one function. Let me swallow what I got in my mouth. Okay, if two functions are inverses, then composing one function in another is going to return a value of x. So we could see here in this situation if that actually is going to work out. So let's say we have f, let's just give it a value of 4. Well, we can just go and multiply 3 times 4 and plus 2. This is going to give us a value of 14. Now, if this is the inverse, it's going to give us a value of 4. So, will it? Let's throw this here. Let's throw 14 inside of here, minus 2, and divide that by 3. And indeed, it does give us a 4. Let's go and graph some functions. Okay. And I'm just going to do this real quick because it's... Let's go and actually just work these out because I just want you to understand the basics of what happens whenever you add constants to a function or whenever you multiply a value times a function and all of the different changes. Do you think you'll bridge this series with a category theory and functional programming? I have no idea what I'll ever do video-wise. I didn't expect to do this video, but I wanted to teach machine learning, and to do that I had to teach calculus and linear algebra, and to understand calculus and linear algebra you need to understand all of the basic algebra. So it's sort of, I was like, I might as well make this, and I might as well make it in one video, and then I can just refer to everything. I never know what I'm going to make videos on. I know this year I want to make a ton of machine learning videos, and the only way I could possibly do it and refer to other previous videos was to do all the math videos. And after I get through the math videos, which actually aren't going to take me that long, I'll probably in 1 month I'll be able to get through all the math videos, so it'll be pretty easy. Okay, so what you see here on the what's next week's topic, I might do trig in one video. I haven't really decided. Next week's going to be kind of hard because I have a bunch of medical tests I have to go through. Anything's possible. Okay, so what I have here, the graph you see on this graph here, is this function right here. So what would happen if we would just simply add 1 to that function? Well, adding a constant to a function is just going to shift it up or down. So if we add 1 to it, it's just going to shift it up by 1 value. So let's go and let's create... I'm just going to roughly draw these in. It's basically going to create, maybe I want to use a different color or something. I would just use red. Okay, so what this is basically going to do is, for the second one, is it's just going to shift this up in like this. Okay, so that's what adding a individual constant to a function is going to do. Okay, it's kind of a sloppy drawing. Bear with me. Now, what would happen if we would multiply, in this circumstance, a negative value towards our function? Well, multiplying a function by a negative is going to just simply create a reflection of that function. So it's going to roughly be, let's say, like down inside of here, and I don't know. Let's just roughly draw it in. I'm going to roughly draw a reflection of what we have here. So it's going to sort of come down here like this, and it's going to come down like this and do that. Okay? So in this circumstance, whenever we are adding a constant, we're just going to either be moving it up or down, depending upon if the constant's positive or negative. And if we're multiplying it times a negative, we're going to create a reflection of the value that we have. All right, so let's get rid of all of that. Okay, so now we'll move on to the next one. So what would happen if we would multiply it times a fraction? Well, in this circumstance, it's going to create a function that is going to be half the distance from our x-axis. So that is going to put it, maybe I should use a different color. Let's go and use this guy here instead. So it's going to just make it go closer to the x-axis. So let's go and, I don't know, just go underneath of it. So it's going to go something like this and like this. If we would instead go and multiply times a positive value, it's going to be twice as far away from the x-axis. So it'll be more like this. Okay? So that's just a rough sort of overview of exactly how that works. And then if you would use absolute values, what you're going to do is convert all the y values positive. All right? So just a brief overview of exactly what happens with a function whenever you multiply, add to it, divide, and so forth and so on. Now we move on to whether a function is going to be considered even or odd. Start making videos like making your own. I started actually making electronics videos, but people didn't seem very interested in them. I actually was going to make a computer just based off of chips. I started off making a basic calculator. I recreated the game of Pong just using transistors and stuff like that, and people didn't seem interested in it, so I just stopped doing that tutorial. There's so many things on my YouTube channel that most people don't even know exist. Like I said, a lot of people know I have crochet videos because I just re-uploaded a amalgamation of all my crochet videos, but I have weird videos on like everything. I have a whole entire video series where I recreate junk food using healthy alternative food. I mean, I have like all this really weird stuff. Yeah, basic electronics are kind of complicated. Okay. So what I want to do here is I want to figure out if a function is going to be considered either even, odd, or neither. So if you substitute a minus x for your function and get the same function, then in that situation the function is going to be easier. Yes. I don't even know what healthy food is though. I'm a particularly healthy eater, and I'm sick right now with, I have like this thing called long COVID. And they said it mainly affects people that are healthy. So keep eating junk food if it makes you happy. Okay, so what that means, what I just said, is fx is going to be equal to f negative x. In that situation, it will be considered even. All right? So in this situation, you can see basically what that's saying is the functions are just going to be symmetric upon the y-axis. So we have here, if we take f to the negative x, this is going to give us negative x squared plus 2, which is going to be negative x squared plus 2. And you can see in this situation that x squared plus 2 is indeed equal to x squared plus 2. And in this situation, a negative times a negative is always going to be positive. All right, so there you have an example of a function that is even. Let's see, do I have another one? Yes, I do. All right, so in this circumstance, we're going to do the same type of thing. Odd functions are going to be symmetric about our origin. And to be odd, the signs need to be the opposite of whatever the original function was. So in this circumstance, we have fx, or x to the third minus 2x. If we go and throw a negative value inside of this, we're going to get negative x to the third minus 2 and negative x, which is going to be equal to, negative 3 to, or x to the power of 3 plus 2x. So in this situation, we can see that x to the power of 3 minus 2x, and this is going to be x to the third plus 2x. So in this situation, we know that this function is going to be odd. All right. Now let's move on. Let's say, do I have another one? Yes. This is going to be a situation in which we have neither. And the way this is going to work out is if we go and get and make x negative in this situation, we are going to get equal to negative x to the third plus and negative x squared minus 2 negative x plus 2, which is going to be equal to x to the third, or no, negative x to the third, sorry about that, plus x squared plus 2x plus 2. So in this situation, we can see, let's not rewrite all those out. We can see that indeed that, change this to an orange color. Okay, so we can see in this situation that this guy right here is not going to be equal to this, so it's not going to be even. And also we can see that negative x to the third minus x squared plus 2x minus 2 is also not equal to negative x to the third plus x squared plus 2x minus 2. Okay, so in those situations, they are not even or odd, so they are considered neither. All right, and this brings us into another concept. We're actually very close to covering almost everything. I got to take another break because I need more water. Sorry for the breaks, but otherwise my voice dies and the stream ends early. So up next is Asymptotes. I'll be back in a minute. All right, I'm back. I got some tea. I tried to find a lollipop or something to my kids are like cookie or candy monsters. Any candy in the house, just they eat it all. Boy, this is a long stream. Okay. So let's continue. Now we're getting into the part that, not asymptotes, but we're right after this is what actually first made me really get fascinated with mathematics, which are logarithms and Euler's number and such. Okay, an asymptote is just a line a curve approaches, but it goes off into an infinity. So here is an example in which we have one. What we're going to be able to do is we can find the values of x where there is no value by finding the x value that makes the denominator equal to 0. So we got this x plus 4. So what we're going to do here is we're going to get to the x squared plus 2x minus 8, and we are going to give it a value of 0 and figure it out. So very simple. We'll just go x plus 4. We've already worked out how to solve these types of problems earlier in the video. Is going to be equal to 0. And we find out that these are x is going to be negative 4 and, or well, we should say, or x is going to be equal to 2. So our vertical asymptotes are going, let's just write A, is going to be at x equal to negative 4. Oh, I should write and 2. All right, so there you go, asymptotes, and that is how quickly and easily it is to find them. All right, now we come into logarithms and Euler's number and a lot of interesting stuff. You can do really cool complicated calculations very, very easily. Now, we have our exponents, and what the exponent does. It just tells us how many times to multiply a number times itself. So if we have, for example, 2 to the third, of course, this is 2 times 2 times 2, which is going to be equal to 8. Now, what makes a logarithm interesting is a logarithm is going to tell us what the exponent is. So if it would be 2 with a big question mark equal to 8. This is going to become our log like this for 8. And it is going to give us a number which is going to be equal to 3. All right? So that just tells us what the exponent is. Now, that might seem rather boring, but it gets much more interesting. Now, if we wanted to find n, if we have this function right here, how would we do it? Well, we would just have n is going to be equal to 2 to the power of 3. And which, of course, is 2 times 2 times 2, which is also going to be equal to 8. Now, let's go and solve this next problem. It works in exactly the same way. This is just going to be equal to 2. Now, in our next situation, let's go and get 25 and convert this to n. This is going to be equal to 5. That is exactly the same as if we would take n and run it like this, and equal to 5 to square root of 25, which is going to be equal to 5, which is the same as log 25, 5, and this is going to be equal to 1/2. All right? Now, a base 10 logarithm, is that what I have here? Base 10 is how many times do we use 10 to get to a specific value. There's different types of logarithms. Now, in this situation, how many times do we have to multiply 10 times itself to give us a value of 100? Well, of course, this is going to be equal to 2. A natural logarithm, to differentiate itself, is going to be how many times we use Euler's number, which is this guy right here, in a multiplication to get a specific result. And let's go and let's work this out. So this function we have here is going to be equivalent to 3x equal to 1/9, and 3x, we're going to use the fraction as a negative exponent in this situation, is going to be equal to 9 and -1. And if we then go and get 3 to 1 like this, x, this is going to be equal to 3 squared -1, and this is going to then be equal to 3x equal to 3 to the power of -2, and in this situation we know that x is going to be equal to -2. And I'm going to provide a link to all of my notes so you can download all this stuff for free after the video. I'll put it in the description for this video on Twitch, and then on YouTube I'll put it in the description on YouTube. So you'll be able to download all this stuff, and I won't charge you anything, I promise. Okay, so then we continue to solve, and it's just basically the same exact format again. Whoops. This becomes 3, of course, and then this is 27. So we're basically just juxtaposing around the different values. That is all that's going on here. And again, this is going to end up being x to 4/3 is equal to 16. And this gets to be a little bit more complicated. Let's go x 4/3 like this. 3/4 is going to be equal to, and just run this like this, like that, 16, and we'll take these to the power of 3, and this is then going to give us a value for x of 4 and 24, or 2/4, and this is going to be to the third, and we can bring that 2 out of there, and this becomes 2 to the third is equal to 8. All right, natural logarithm. Now, let's move on. Logarithm is also, we got some little rules here. We're going to be able to, well, let's just work through this. I don't think I need to cover that again. Basically, what we're going to do is just work through these problems and figure them out. So this guy right here is going to be exactly the same as this natural logarithm, 3x squared y. And let's go and find the difference. Well, that's just going to be this guy right here in this format. And let's move on to our next one. This again is just going to be this natural logarithm, and it'll be x squared y over 3, and that's about all I got for that. All right, let's move on to some more interesting stuff, because it's basically, when you're working with logarithms, you're just juxtaposing different values around depending upon those. Now let's get into Euler's number. Can you see these values? I think you can. So basically what's awesome about Euler's number is it is the rate of growth for all continually growing processes. And we're going to be able to do really cool things in regards to organic matter and life and investing and things like that with Euler's number. Let's go and what do we want to do here? Figure out exactly what we got with my different examples that we have here. Okay, so what this is EX is going to represent the amount we'll have after starting at 1. So let's say, for example, like an investment. You make an investment of $1. How much would you have at the end if it continually grows over X units of time? So what we're going to do is just show you an example so that everything makes a lot more sense. So let's draw like a little graph here. So I'll draw this line here and this line right here. And this is going to be on day 1, and this will be on 1. So what we want to do is let's assume you found an investment that is going to double your money in 1 year. How is that going to work out? So this is day 0, the very beginning, and then this is going to be at the end of that period. Well, so you're going to start off with an amount, which is going to be your investment amount, and at the end of the 1 year, remember it's going to double your investment, you're going to have your original investment amount, plus you're going to have your return on your investment. So, good stuff. The thing you have to understand, however, is that your return isn't going to happen all at one time. It is going to increase gradually to eventually double your money. After 6 months, for example, you're going to have 50% more money and then at the end of the year, you'll have 100%. But a thing that's important to understand is your interest is also going to be accumulating additional interest. So let's go and change our form here just slightly. I'm going to delete this part, and I'm just going to delete this whole thing. So let's get rid of that. And let's start looking at how your investments are going to grow over the halfway mark as well as the final year. Now, at the end, or at the 6-month mark, you're going to still have your original investment, but you're also going to have a 50% return on that investment, because remember, it's growing by half to get to the final where it doubles your money. So how is it going to work that at the very end of this period of time, you're going to have your original investment, but you're also going to be able to double your money? What would happen, you may say, if you as an investor were able to constantly double your money? Well, Euler's number is going to be able to help you figure that out. So let's do another thing. Let's use real money, because I think that kind of makes things more understandable. So we're going to start off here. We're still going to be using the starting point. Let's say you invest $1. Okay, so you have $1 you invest at this point. And then at the end of the year, you're going to have $2. Okay, so we know we're going to head there. Well, what are we going to have at the middle point? Well, you're going to have your original $1 investment, and then you're going to have a 50 cents of additional investments. So what we're going to do is really sort of wrap our mind around the whole concept of, because we know that interest is going to provide us a return along with the different investments, how can we go, or can we actually generate an infinite amount of money if we collect interest at different targeted time periods? Or even better yet, what would happen if we were to invest money and we constantly were able to get a return on our money? Well, there's actually a formula for this, and the formula for calculating the total over a given number of time periods is going to be this formula. So 1 plus 1 over n to the nth, where n is the number of time periods and 1 over n is a 100% growth over a certain number of periods. Now, Euler's number, which I'm going to write it in here again because it was on the previous slide, is roughly this. It represents the maximum possible result if you were to compound 100% growth over any given period of time. And every rate of growth can be written using this basic universal constant, which is why it is so fascinating. So let me show you some different examples. So what if we grow by 50%? How exactly would we model that? Well, or how exactly would we create that in an equation? Well, we could go 1 plus with the formula that I showed you before, and you're just going to put 50. That is your 50% growth, n over n, which is going to be equal to 1.648, which just so happens to also be equal to Euler's number if the exponent is 1/2. All right. Now, what is the total with a 200% growth? Well, to figure that out, all you have to do is go and get Euler's number to the power of 2, which is going to be equal to 7, 3, 8, 9. Okay, so if you had a 200% growth rate over a certain period and you invested $1, you would know that that actually is going to grow to $7.38 roughly. Now, we can also use different times. Like, let's say we wanted to say if we earn 100% in a year, how much would we have after 6 months? Well, that actually works out to being equal to Euler's number. So what did we say? 100% a year is what at 6 months? Okay, so if we had 100% at 6 months, that's going to be Euler's number, and this is just going to be rate times time, exactly like that. So that's going to work out to being Euler's number to 1 times 1/2, which is going to be equal to 1.648. So that's going to allow you to do that, which is even more interesting. Let's say we wanted to find out what would be the total at an 8% return after 10 years. We can do that. We can just say Euler's number again times, well, what is our return? It's going to be 0.8% times our period of time, which is going to be 10 years. And if you work out that calculation, you're going to get 2.225. So if you got an 8% return on your money for a 10-year period, it would be converted into $2.23 roughly. Just keep using basic numbers here just to keep it simple. How did I get rid of the n in the first example? If we grow, well, basically, I'm just transitioning from using Euler's number and I've basically just replaced it. that was sort of what I'm saying is half of Euler's number is going to tell us if we grow at 50%. So it's sort of, I'm axing this concept of using this formula, and I'm instead choosing to use Euler's number because it's going to provide me with exactly the same thing. Sorry if that was confusing. Let's see here. Let's see. I got sort of lost there for a second, so I apologize. Now, basically, with Euler's number, it's going to provide a growth over a certain period of time. With a natural logarithm, what it's going to do is you're going to receive the growth and returns. So what we're going to do here, for example, let's say you had like log E1. Well, that's going to be equal to 0. And the reason why is basically what you're asking with this equation is how long does it take me to get what I originally already have? Well, it takes you exactly 0 periods of time. It's like saying I have $1 in my pocket. How long until I get an additional one, or how long until it becomes $1? Well, you already have $1, so it takes you no time in that situation. If you wanted to find out another thing that is important is, let's say you have log E negative 1. In this situation, it would simply be undefined, and the reason why it's undefined is it's not possible to have a negative number using these tools. Let's see. Let's say you wanted to find out how long it would take to double your money. Well, what we're going to do is just take this natural logarithm, and you want to double your money, which is the same as saying 2. This is going to end up working out to 6.93. And in time base, what that would be equal to is 8.3 months if you were working off that calculation. And that would be if you had a 100% interest rate that compounded continuously. What else do we have? Oh, you could say something like, how long would it take to double your money if you had a 8% growth rate? So again, you're going to take the rate times the time, which is going to be equal to 6.93, and you would then get 0.693 divided by your interest rate, which is going to be 0.08, and that means that it would take 8.66 years. All right, and there's multiple different ways of playing around with these to get sort of interesting answers for all this. But now what I want to do, Q&A section in the stream. Yeah, what you can do is if you have any questions, well, I'm going to be uploading this to YouTube, so you can leave any questions there. You could also leave questions in chat. And this whole entire stream that I have here, I'm going to make a notepad, like a little notepad thing in GoodNotes, which is in PDF form, and I'll make it available for everybody to download. I'll put it in the description for this video, and on YouTube, I'll put it in the description on YouTube. You can get it there, and then I have a Discord. You can ask me any additional questions that you have. If you want my Discord, here, I'll give it to you. Let me see if I can give you a link to my Discord. And I'm on there pretty much constantly. You can always ask me questions. Why can I not get a link to my Discord? Sort of. There we are. All right, so get this, and invite link expires never, and there we are. So generate link, and where is it? All right. Copy. Generating a link to my Discord. You know what? I'm just going to grab it off of YouTube because Discord's acting weird here right now. Where is it? I am not going anywhere. I'm just bouncing around in browsers trying to get the Discord channel. Any questions that come up during this video, the best place you can ask them is on Discord because I'll answer anything that you want on there. Just give me one moment to get a link to my Discord. There it is. There it is. All right, I'll post this inside of the chat, and then you can go there. So put this right like this. Boom. There it is. Okay, just go there, ask questions, and I will answer all of them that I get. All right, so now let's figure out where exactly I am here. I'll bring this back up aside of here and go back to this. All right. So now what we want to do is we just want to solve some logarithmic functions to sort of end this tutorial. And yeah, I guess we're done. I guess I've covered all of Algebra 1 and 2 except for matrices, which I will cover in the linear algebra thing. Now, logarithmic functions are going to allow us to isolate the variable exponents. So in this situation, did I write this out? I did not. Okay, so let's write this out. So what we're going to do here is to solve x squared equal to 4. What we can do is we can find the square root of both sides, and we can get x is equal to 2. Well, we can also do the same with 2x to, like this, equal to 4. Exactly like that. So in this situation, x equal to 2 to the power of y is going to be the same as y is equal to the log of 2x. So let's solve this problem right here. So all we need to do is go and change it into exponential form, which is going to be equal to 5 to the power of x is equal to 25. Okay? Very simplistic. Also, if we wanted to solve 2 to the power of x equal to 16, we can put this in log form like this. 16 is equal to x. And likewise, another thing is log, just so you know what the technical terms for everything is. If we have 4/16, just to use an example, this is called the argument, this is called the base, and this is called our exponent. All right, so there's that. And let's solve a couple more of these problems. This log to the 636, of course, this is going to be equal to 2. And if we have 1/8, maybe we want to draw an arrow here. Well, we can go and get 1/8, and this is going to be the same as 1 over 2 to the third, which can be converted into 2 negative 3. So this is going to give us log of 2 to the 1/8 equal to negative 3. I like that. And for this last one that is slightly more complicated, we can convert this into log to the 5th and 5 negative 1 over 3, which is ultimately going to give us a value of 1 over 3. And there you go, guys. That is basically at least one problem on just about every algebra concept you could ever possibly imagine. Let me see if I can go and give you the link to the notebook right now as while you're on here. Do I have it somewhere? I am going to put it, probably going to throw it on my OneDrive. Is that where I want to put it? Let's see. I will throw it, or maybe I can throw it onto, maybe I'll throw it on Dropbox. That might be best. So what I'm doing right now is I am getting the entire notebook, and I'm going to put it on Dropbox so that you can download it. I'll give you a link to it. If I can remember my Dropbox password. Do I remember it? No, I do not. Okay, well, it's going to go on OneDrive then. Well, thank you for sticking around. It was a lot of information. I'm actually kind of surprised I was able to survive through the entire video. My voice is completely raw right now. Oops. Yeah. If you're wondering what I'm doing, I'm trying to save everything, and I accidentally keep hitting my caps lock. so that I can give you the notebook that I have here. So where do I want to save this? It's documents, and you can work through all the different stuff. Let's put this into a directory here, and I can just throw it right here. Okay, so I'm going to get you the notebook that you can download, and you can look at every single thing that's inside of it. So I have to locate the file first. There it is. And I called it all the algebra. I think that's what I called the file. Yeah, all the algebra is what the name of the file is. So let's drop it right here. And it is uploading, and as soon as it uploads, I will give you the link. And then you can download everything. It's written, it's all handwritten. So it's really kind of funny. And uploaded one file, all the algebra, and I'm going to try to get you a link. I don't know if you ever used OneDrive or anything like it, but it's, for some reason, it takes forever to upload. Hey, no problem. To anyone with the link, I don't want you to edit it. So allow editing. I'm going to say no. You can download the file though and do whatever you want with it. Specific, allow editing, set expiration. No, that's fine. Apply and copy link and copy, and let me verify that the link actually works before I give it to you. And it looks like it did. There it is. Yes, this is all my notes from this entire video. So, whole bunch of crazy stuff. One thing I'd suggest is maybe put a dot on the 3 places you're referring to, since we can't see it. Oh yeah, I apologize for that. Let's go this and this here. And I will create a link, OneDrive, and create. And what nice name could I give this? Can I get all the algebra? All the algebra as a bit.ly. Let's see. Link's been saved. Look at that. I got that. I'm verifying it works. Looks like it does. And I will post it right here. Boom. There you go. Oh, that was dumb. Just went through all the effort of getting all the algebra, and it didn't work. Here, let me get it. just for the heck of it. Get this, and oh, okay. Well, thank you very much. I thank you very much for stopping by. I greatly appreciate it. So let's just copy this link. If I can get it. And copy. So it's also here. It's a lot easier to remember all the algebra, at least I think so. So there it is. All right, guys. Well, that was a 3-hour live stream. Thank you to everybody that joined me. I'm going to try to do a Learn Trig in one video next week, but I cannot guarantee it. I might have to move the time because I have to go to the hospital and get random stupid tests that I can't get moved, so whatever. So thank you to everybody that joined me today. This will be on YouTube tomorrow. So I'll see you next time.